This last example puts in something new, which are exponents. And so before I start trying to solve this example, I want to talk about how we show exponents on a trig function. Because when you write a trig function like this, if I wrote the cosine of pi over 4 squared, this is super ambiguous. Even if I put parentheses right here, do I square the angle? Do I square the cosine? Really, the least ambiguous way I could write this is if I use all of these parentheses to say I'm going to take the cosine of pi over 4 and square it. But that's kind of annoying. Surprise, mathematicians are lazy. So in order for me to denote that I want to square an expression using a trig function, they put the square right by whatever the trig function is. So really, both of these expressions mean the same thing. However, you're going to figure out what the cosine of pi over 4 is and then multiply it by itself. Okay, so again, this square being up in this expression just means I'm going to figure out what the cosine of pi over 4 is and multiply it by itself. Again, we don't put the square on the outside because it gets a little bit too ambiguous or there's too many parentheses going on, so they're going to put the little square up in the top. So my goal for this is I'm going to find one expression, square it, and I'm going to find the other expression and square it. So it'll have the same problems steps that I did before. Okay, the first thing I want to find is I'm going to end up finding the cosine of pi over 4, and then I want to find the sine of negative pi over 4. So I'm going to have two separate trig things that I'm looking for here. So the first one I'm going to find is the cosine of pi over 4. Again, I'm going to draw my angle out. It's in the first quadrant. Pi over 4 is a 45-degree angle. So my legs are the same and my hypotenuse is root 2, and everything will be positive because I'm in quadrant 1. So the cosine will be my adjacent over my hypotenuse. So 1 over the square root of 2. So I can replace the entire expression cosine of pi over 4 with 1 over the square root of 2. Okay, I'm going to do the same thing for sine of negative pi over 4. Okay, the only thing here is now my angle is negative. So I'm going to go ahead and instead of going up and around, I go down and around. So negative pi over 4 is hanging out in quadrant 4. It's still a 45-degree reference angle. So the only thing that changes is that opposite leg becomes negative. And in this case, my sine is going to be my opposite over my hypotenuse. So now in my expression, I can replace the sine of negative pi over 4 with negative 1 over the square root of 2. And now what I have here is just a normal algebraic expression that I would like to try to solve. So again, I'm going to use my PEMDAS rules, and I'm just going to square the things. So I have, when I square 1 over the square root of 2, I'm going to get 1 over 2. Root 2 times itself is is positive 2. Then if I square a negative 1, that becomes a positive 1. So again, square a square root, you get itself. So I have 1/2 plus 1/2, 2/2, or just 1. So again, the big moral of the story here is this little square just tells you you're going to figure out whatever that expression is, sine, cosine, tangent, whatever, of the angle, and then take whatever that number is and multiply by itself or just square the number. Okay, so again, I could have gone through here and said 1 times the square root of 2 times 1 times the square root of 2 plus negative 1 over the square root of 2 times the negative 1 over square root of 2, or I can just square each piece individually.